Okay, thank you, Matthew, and good afternoon, everyone, and welcome to Cost Avoidance session number 4, dedicated to EnergyCAP Cost Avoidance Reports. This is webinar number 4 in a series of 4. A number of weeks ago, session number 1 was on the fundamentals of measurement and verification of savings, and then from there we moved into calendarization and normalization of data. Session number 3, 2 weeks ago, was the basics of EnergyCAP cost avoidance. I went over how you operate the cost avoidance functionality in EnergyCAP. And today, session 4 is all about the reports. Some things in review: the cost avoidance measurement and verification module in EnergyCAP adheres to the calculation requirements of IPMVP, that's the International Performance Measurement and Verification Protocol, an international document that's maintained by a nonprofit organization. We conform with option C. EnergyCAP's cost avoidance module has been used in essentially the same format since 1985, so that's 30 years of the same basic methodology, so it's very tried and true. Over 20,000 buildings have had cost avoidance used on them to calculate the savings attributable to energy management and energy conservation initiatives. There's some limitations that I like to highlight every time I talk about cost avoidance. And first of all, if you've implemented multiple projects in a building, it's difficult to discern the results of each individually. So if you did an HVAC retrofit and an LED lighting retrofit, don't expect to look at a cost avoidance report in EnergyCAP and it show you what you saved due to the HVAC project separately from what you saved due to the LED project, because we're looking at the building as a whole, the building as a blob, by primarily looking at the utility bills. So there's not individual sub-metering on circuits or anything to be able to break those apart. There are other M&V methodologies that would be used in that case if you need the granularity. Something else I like to point out is the further back your baseline year is set, I would say the less reliable the calculations, because many changes take place in buildings over time. EnergyCAP allows you to enter special adjustments to take these changes into account. But if you go back too far, no one even remembers what was going on 10 years ago in the building. So there's a good chance that the adjustments are not being done appropriately. Also, if peak demand charges, if KW charges are a major cost driver, then there's valuation complexities that you need to take into account, because the basic methodology in EnergyCAP is average unit cost. It's not doing a rate schedule recalculation. There's some reasons for that. So you need to take that into account. And if you have to do non-standard baseline adjustments, they require engineering analysis. It's a high skill level and substantial time commitment. If you're expecting to do very detailed EnergyCAP M&V on a wide range of buildings with a lot of things changing in those buildings, that is a complex and time-consuming and high skill level task to make adjustments that need to be made in all of those buildings. Now, let me move on. Terminology used on reports. I think it's good to start off here because you're going to see this terminology over and over again. First of all, there's the actual use and cost. Where you see the word actual, that means data that's pulled right from utility bills. What you see on the report, if it says actual cost or current cost, you should be able to pull the utility bills out of the file in the accounting department, and they should reconcile. Keeping in mind that if there are any non-meter charges on those bills, let's say late fees, generally the late fees are not considered to be part of the meter cost in EnergyCAP because that's really not, let's say, the fault of the energy management program. You could say it's the fault of the accounting department. So if done correctly, we keep special charges like late fees separate from the meter charge, so they are not included in the actual cost. And then on some of the reports, it shows the baseline cost and use. One of the principles of option C is that you select the one-year baseline, usually the year immediately before your energy savings initiative started. So you'll see some of the reports show the baseline data, the baseline cost and the baseline use. That is data that's right off of the baseline utility bills. It's not massaged or adjusted in any way, except that it is trimmed so that it aligns with the same number of days as in the current bill. So if we show you today's bill that was 32 days, and then we show you the baseline data, that's going to be 32 days of baseline data, which might have aligned exactly with the baseline bill, but then again, maybe it didn't. Maybe the billing dates changed. So we might have had to grab some days from one bill and some days from another bill. So just be aware of that. They don't necessarily align 100%. Over the course of a year, they would add up 100% accurate. There's another term that's used frequently in cost avoidance called BATC. BATC, an important concept, is the baseline adjusted to current conditions. It's the adjusted baseline. Because when we make a comparison, we want to compare apples to apples. So we take the raw base year and we make adjustments to it up or down so that the conditions are the same as the current year. The weather conditions, the number of days condition, the average unit cost condition, and things like that. What you could consider the BATC to be is what you expected to spend and use had you continued the, quote, wasteful ways, I'm doing air quotes right now, the wasteful ways of the base year. Now, presumably you have not continued the wasteful ways of the base year, so that your actual is lower than the BATC. That's what we would like to see. And finally, cost avoidance dollars, is the BATC minus the actual cost. In other words, the BATC, again, is what you expected to spend had you continued your wasteful ways and experienced today's weather and today's other conditions, minus what you really spent today, hopefully a lot less because you implemented something. The result is cost avoidance. And then we calculate a cost avoidance percentage. That is the cost avoidance divided by the BATC cost. In other words, it's the percentage of what you would have expected to spend that you avoided. And on some reports, you'll see a terminology called other savings. Other savings is an EnergyCAP feature where you can enter savings directly into EnergyCAP that are directly included on reports for things that are not part of the normal M&V process. Let's say you got a rebate. The utility company sent you a check for some reason. And it's because of something that you did with energy management. So you want to include that on your reports, but it was not reflected on a utility bill. It just is outside of the normal M&V process in EnergyCAP. So you can go into EnergyCAP and say, I got a rebate for $5,000. It was a one-time thing, and include that on my reports so that when I present those to the public or to senior management, I get, quote, credit for that. And again, to illustrate the basic principle here, in orange is today's bill, the actual current use. So in this case, this is my electric bill in July. My bill today was 500,000 kilowatt hours. That's exactly what was on the bill. If I look at my baseline bill was 560,000 kilowatt hours. The baseline is on the far right. That's the actual baseline. But we never compare the actual current with the actual baseline because some things changed, and we want to compare apples to apples, so we have to make the baseline look like today. How do we make it look like today? Well, we have to take today's weather and put it into the baseline and say, what would we have spent in the baseline had we continued our wasteful ways, but we were subject to today's weather? Maybe today's weather was better, maybe it was worse. In this example, today's weather was more severe. And because the weather was more severe, it was warmer in July, the baseline was adjusted up a little bit, and that created the BATSI. The baseline adjusted to current conditions of a warm month. So that was 582. Now we calculate avoidance by comparing the BATSI with the current. In this case, we're looking at the usage first. So the BATSI was 582 minus the current is 500. So we had use avoidance of 82,000 kilowatt hours. And then we value that using today's blended average unit cost, the average that we're paying per kilowatt hour today, and we come up with our cost avoidance. That is the refresher from last week and prior session. The reports that I'm going to show you in just a moment are at 3 different levels. There's a summary level. That would be an organizational level to show total performance across all of the buildings that you're running cost avoidance on. And then next down is building level. These are reports that show individual buildings, either one building per page or many buildings on a page. That's very useful for identifying which buildings are the big savers and which buildings might be the big losers. And it also might be good reports to distribute to building managers. And finally, we'll go down to a lower level, the meter level, meter by meter, and also individual utility bill level. Okay, so let me move into the live demo portion of this. We are using Loudoun County Public Schools. Thank you, Loudoun County, for allowing us to do that. And I'm going to move into the reports section of EnergyCAP. Most of what I run is going to come out of the cost avoidance report section, noting that once I run a report, it's going to appear in most recent. We do that as a convenience. It's basically creating a favorites list for you automatically so that you can very quickly find a report and run it. Now the first one I'm going to run is a new report that we just created called Abnormal Weather Dates. The purpose of this report is to ask the question, on what days in some length of time did we have weather that was abnormal? The reason that's important is because when you have abnormal weather, you might have operated your building differently. If you were concerned about sprinkler pipes freezing, so that when you get below a certain temperature in certain buildings, maybe older buildings that aren't insulated as well, you go into freeze protection mode and crank up the heat all night long, because spending some extra, using some extra energy is better than having a burst pipe. Now you're not in a normal operating mode, and if that happens for some length of time, a number of days, you might want to create a special adjustment, because you don't want that to reflect negatively on the success of your energy management program. It was an operational necessity, but it shouldn't make the building performance look bad. So I have this report set up in a date range of a year, and you give it a trigger temperature. I'm saying, show me all the days in this date range where the mean daily temperature was less than 25. Now this trigger temperature, again, let me stress that. This is not the low temperature for the day. This is the mean daily temperature, the average daily temperature, because that's what we track in EnergyCAP. So if my mean daily temperature was 25, it means maybe I had a high of 30 and a low of 20 or a low of 15. And I'm running this for Dulles Airport. Now I've already run some of these reports just to speed it along. So here's the report that I ran, and it's showing me that in the date range I selected, there were 12 days that fell below that trigger temperature. and if the building operating people are telling me that's the point at which we go into freeze protection, I can see that there were some stretches of days here where I might have been in freeze protection for a whole week at once, therefore explaining why my energy use might be significantly more than I would hope. Okay, that's a brand new report we just rolled out this month, Weather 04. The next one I'm going to run is the CAP 19. The CAP 19 is one of the most popular reports. Our users combined ran about 1 million pages of cost avoidance reports in 2016. I like to say, hopefully you didn't print all of those out because we're not trying to kill trees, but our statistics show about 1 million pages of cost avoidance reports. So we know which reports are run the most frequently, and CAP 19 is one that is very popular. So I have this set to run for all high schools in a certain range of billing periods, and it looks like this. It's a nice report. It shows the cumulative savings trend. It shows the expected energy cost, in other words, the BATC cost, minus the actual is the savings, the percentage, and then there was other savings. That's the rebate refund thing I mentioned earlier that was programmed in by the user to show a total savings over this period of time. So it shows that we saved a nice chunk of pie, and then it also explains the terminology used above. Down below in this report, we show the greenhouse gas reduction, some metrics having to do with that. So it's a nice report to show at a high level of an organization to show the overall impact of the energy conservation program. Next is the CAP 21. In some cases, folks like the CAP 19, but they want to see more detail. So the CAP 21 is another one that's very popular that shows more detail. I ran this for the same filter conditions as the CAP 19, but you'll see that there's a different format here. And there's the CAP 21, because this shows me year by year and month by month. So we can see what the cost avoidance was, the percentage. You notice the other savings and the total. And then as we go page to page, it runs year to year. I ran this for multiple years. That's why we have multiple pages. And on the final page is a very nice summary. The reason why I would say the summary is so nice and useful is that it shows use as well as cost. So it shows how many kilowatt hours, how many therms were in the adjusted baseline, the BATC, the actual, how many we avoided. So now we can see units of energy that we avoided, as well as cost avoidance. And these numbers would reconcile with the same thing that you would see in the CAP 19. Okay, moving on, there's one more that I want to show, and that's the CAP 07. The CAP 07 has even more detail to it, but sometimes people want to see this level of detail. The first time I ran this, I did not have a topmost place filter, which meant it ran for everything, all facilities. Oh, not the right one, there it is, CAP 07. And so this has one page per commodity. We don't really care about diesel fuel and move on to electricity. It always shows 12 months worth. So when you run the report, you say, I want to run it for November of 2016. You give it the end month, and it backs up 11 more months to show you a complete year. And you can see it gives us a lot of detail. The actual baseline, the BATC, the current and cost avoidance percentage and cost avoidance dollars, both monthly and year to date, both use and cost. So you get a lot of detail on this report. It's really showing you all the numbers that are used on all cost avoidance reports in EnergyCAP. So it's a good one if you need that level of detail. That's the final one I wanted to point out at the high level, the organizational level. And let me backtrack, because there's one thing that I wanted to mention about my configured reports. Let's say when we ran this weather report, we ran the Weather 04, we look at this and we say, hey, this is a good one. I want to save these filter settings because I want to run this periodically, and I don't want to have to remember what filter settings. I want to sort of lock those in. So we can say add to my configured reports, and then we can give the report a name. I'm going to call it extreme cold weather. We can give it a report code of whatever you want. I could call it special report that I'm producing, so it's Steve Report 01, because I might have a whole list of these, and I say add report. Now what that did was it took these filter settings and it created a record in my configured reports. So when I go to run that, it has these exact filter settings. And because I could give it my own name, it means I could have taken that same report and copied it multiple times to my configured reports, giving it a different name and different filter settings every time. That is a real convenience feature, because if I want to run the Weather 04 report multiple times with different trigger temperatures, instead of cycling back, changing the filter, I could just go to my configured reports and pick it out of the list and run a report multiple times. So if you haven't done anything with my configured reports, you might want to give that some thought. Okay, next I'm going to move into the building level. The first one I want to talk about is a building report, CAP 01B-2. We have several versions of the CAP 01B. All of these reports have rows of buildings. In other words, it's a list of buildings, and it shows you how each building did, but some of them are sorted differently, or the format is slightly different. I'm going to run the CAP 01B-2, and I'm running it for all buildings with this same 4-year date range, 13, 14, 15, 16. And that report is this one. This version of it, the -2 version, separates the buildings by primary use. And what I like about that is I can see all of the elementary schools in the same category, and I can see all the high schools together and the middle schools together, because it's often valuable to be looking at different categories of buildings when I'm going down the list and saying, hey, who's doing well, who isn't, what am I averaging? So across all my high schools, I'm averaging almost 28% cost avoidance, and I can see those who are exceeding that and those that probably need a visit to find out what's going on. This particular building has a negative savings, and there might be very good reasons for that, but it points out that if I want to focus my efforts somewhere, that'd be a good place to go, because there's a lot of dollars at stake, and for some reason the performance is not what I would expect. That was the CAP 01B-2. The next one is the CAP 07. The CAP 07, when run with a topmost filter, will give you 1 page per building. So when I run it with that filter in place, notice that I get a banner on the top that gives me a specific building. So if you want it building by building by building, and this report goes on for 54 pages, so for every building, all my high schools, that is, that was what my filter was set to. For all my high schools, I have 1 page per commodity, In other words, one set of reports. In that case, it was 3 reports for that building, and then it moves on to the next building. So it's a way that with one run of the report, you can get a set of output per building. Next is the Cal 28. The Cal 28, notice it's in calendarized. It's not in cost avoidance. Cal 28 is not a cost avoidance report. It is not showing you cost avoidance data. It is showing you actual utility bill data that has been calendarized. We talked about that in lesson 2. In other words, smoothed out into calendar month cells. Now, this is not a cost avoidance report, but for some of you, running full-blown cost avoidance and EnergyCAP might be a challenge. It might be that you don't need that much power behind your reporting. What you really need in your organization are some reports that say, what did we use last year? What did we use this year? Kind of basic stuff without taking that deep dive into everything that cost avoidance entails. So this Cal 28 is a good one for that. Cal 28 is about the only report we have where you can decide what commodities you want to select for the columns of the report. And you'll see that in a second. So you can pick 4 commodities for columns. You can run it for up to 2 years. This filter says 1 page per building. If you say yes, it means you'll have a separate page per building. If you say no, it means you'll have 1 roll-up page for all your buildings. And the report is very Excel friendly. So when I run that report, I get this, the Cal 28, and it's really nice if you want a picture of your utility bills smoothed out through the calendarization process year over year. So for those 4 commodities that I picked, it's showing me use, cost, and average unit cost, and then the annual total for up to 2 years. A very nice report if you want a concise picture of the actual bills, again, subject to the calendarization process in a building. Cal 28. Next, another one that is not a cost avoidance report. It would be sort of a sit-in report for cost avoidance. Again, if you don't want to do full-blown cost avoidance, but you want something to distribute to the buildings that's maybe more graphical to show people how they're doing, because it's not cost avoidance, it's not, we're not making year-to-year weather adjustments. So this is actual data, but showing 2 years of it. This is the YY19A. We created this for a client who said, we don't want to send cost avoidance reports to our building managers. We don't want to go that deep with them. We just want them to be able to compare last year to this year, kind of get a macro view of it. So that's YY. YY means year to year. YY19A. And you can decide what 2 years you want to show because you're comparing 1 year to another. You can tell it what month you want the cycle to begin in. You want a fiscal year or a calendar year, and how many months you want to show. So here's the YY19A. I think it came out very nice. Again, something you'd want to maybe distribute to each building. It shows the pie chart for cost. It shows total usage for the current year, kilowatt hours per square foot, and then for each commodity, we're comparing the 2 years, both numerically and graphically, so you get a good picture of how the consumption is tracking year over year. Are we trending the same? Are we trending higher, lower? If you're trending higher, that could be because of weather. We're not weather adjusting here, so you have to keep those things in mind. But it is a good report to let people know you're keeping an eye on what's going on in the buildings. When the current year is higher use than the base year, on a year-to-date basis, we show it in red. This is cumulative in red. So by the time we get to the end of the year, we ended the year 4% higher than the year before. So cumulatively, 4%, you might say a loss. And we showed in green if we're cumulatively below the prior year. So for gas, we ended up 21% below the prior year. So you would get this for every building. I think that's a nice one. YY19A. Okay, that's the last one that I wanted to show for the building level. Just wanted to mention one thing that we're working on is the CAP 19. Right now, there's no way to run the CAP 19, run it once, and have it give you 1 page per building. So people have said, hey, we like the CAP 19, but I have 50 buildings, which means I have to run it 50 times, and that's a pain. So one of the tickets that's in our system to improve CAP 19, and we'll have that done soon, is adding a filter, again, where it'll say 1 page per building. If you say 1 page per building, yes, you'll get a separate page break per building. If you say no, it'll roll it up to the organizational level. Okay, moving on, we're going to move to the meter level cost avoidance reports. The first one is the CAP 01E-1. This is cost avoidance by meter. So we've gone from the high level of the whole organization down to the building level, down now to the meter level. And it's useful to show things at the meter level because typical question I would ask when somebody would show me a building report and say, well, this building has poor cost avoidance, what do you think the problem is? My next question is, let's look at the meters, because we have to get to that level of detail, find out, is it just one meter that's performing poorly, or is it a lot of meters that are performing poorly? So you need to keep drilling down to get to the heart of the problem. So I'm going to run this for all electric meters for 10 months in 2016 for all the high school meters. So this is the CAP 01E-1, similar to the building report, but this is at the meter level. So we can see each meter, what the actual cost was, what the BATC cost, cost avoidance, and the percentage. So this is a good one to look down this and say, okay, which meters, where did I spend a lot of money and lose a lot of money? When I say lose, again, that's in air quotes, which means I had a negative cost avoidance. There might be good reasons for that, but there might be no good reasons for that. It could be because of mechanical problems, control problems in the building. It could also be because something changed in the building, the class schedule, something like that. But we have not yet created an adjustment factor in EnergyCAP to take that into account. So the impact of the change is using more energy, and it's pulling down cost avoidance. And EnergyCAP says, well, if that happened and you're not to blame for it, it's not you don't want it to be a negative stain on the energy management program, create a special adjustment that's going to add more to the BATC, drive the BATC up. In other words, where you would have been, and it will make your cost avoidance look more reasonable, more positive. You don't want to enter these special adjustments unless they're reasonable and they're justified, obviously. The next one I want to run is the CAP 10. So using the CAP 01E, we said this meter, this meter, this meter have negative cost avoidance. The next question is, do they have negative cost avoidance every month, or is it just because of 1 month? Maybe we entered a utility bill wrong. Maybe something happened just in 1 month that drove it really negative when I run that 10-month report. So now we're getting even more granular at the meter level. So the CAP 10 is a very, very detailed report that I would typically run just on 1 meter because I know what meter I want, or maybe I could run it on one building, but I certainly don't want to run it on everything because you'll run your million pages right there. So you want to really limit the filters on this so you're only getting the meter or maybe the building that you want. This one looks like this. So now it is showing every month in the filter condition. In other words, every bill, each billing period I asked for, and it's showing me what my performance was in every bill. So now I can look at this and say, well, am I losing, do I have negative cost avoidance across the board, or was it just one month that really drove it negative? And I can also see that up here, obviously, because everything below the zero, these are all the months with negative cost avoidance. So it seems like most of these months have negative cost avoidance, which means compared to the baseline, we're doing something wrong in the building, good to know, we want to go correct it, or conditions have changed that I'm not taking into account. Okay, that's the CAP 10. And then along that same line, sometimes you might have to drill even deeper and say, well, let me look at my baseline. Is my baseline reasonable? The CAP 06 is a detailed report that shows your baseline. Again, don't run this for everything. Just run it for a meter or for a building, because the only time you're going to need it is when you're zeroing in and trying to reconcile numbers. So when I run this, it shows me day by day by day baseline for a meter. Now, how did we get day by day by day data? We got baseline bills, and those bills were for 29 days, 30 days, 31 days, 32 days, and we broke those bills apart. We took the bill and broke it into its daily components. And you can see here that the use for these days changes on this day, because that must have been the break between one bill and the next bill, where we had divided by the number of days in the billing period and disaggregated it. And here you can see it changes again as another bill came into play. Now, you also notice that the baseline has the exact same number every day of the month, and it is not showing any weather use. That's because for this particular meter, when we did the statistical analysis of use versus weather, we said that this meter is not weather sensitive. So it has no weather use. 100% of the usage is non-weather use, and we assume it was the same every day. If it was weather sensitive, we would show the mean temperature on that day. We would show a prorated weather use. So these numbers would be populated based upon the severity of the weather. So you'd have to look at one that had weather use, and you would see how that works. And finally, I want to show CAP 23. This is one that's probably not used too much, but it's a very nice illustration of how the baseline, adjusted baseline concept works. So I'm running it for 1 meter for 1 year, and this is what it looks like. CAP 23. In the orange color is the baseline usage. So when you look at this, you say, here is what I really did in my baseline months. And then in blue is what I really did in my current months. Notice that there's a jump in time because of the way I ran it. This is how I tracked in my current. And my green is the BATC. So the green is trending with the baseline. So we started with the raw baseline. Then we created the BATC, the adjusted baseline, which is green, and the blue is my actual. Now, where do we want to see blue? We'd like to see blue way down here. We would like to see blue, today's actual, way below the BATC, the adjusted baseline. In this case, it's actually above the baseline. for many months of the year. So it's showing that for some reason this meter is trending higher. Again, could be a problem in the building, could be failure to make appropriate adjustments. That is the CAP 23. And I wanted to finish up by showing one other tool that is not really a report per se, but is a valuable tool, and that is Weather Data Depot. This is www.weatherdatadepot.com, a website that we maintain using data pulled from AccuWeather. And not, like I said, a report per se, but it does show you weather data and comparison between years. So I pulled this up for Dulles Airport. You can tell it what base year you want to look at, what comparison year. And it shows you the degree days every month. I can drill into a month and it'll show me the daily weather. And then it compares them. So for Northern Virginia, you can see the comparison. This is showing me that in 2016, the first 3 months of 2016 were much, much more mild, many fewer heating degree days than the year before. 50% fewer heating degree days in the month of March 2016 versus 2015. So certainly that reduction in degree days should have had a big impact on energy consumption. But when we get to the end of 2016, the heating degree days were way up compared to 2015. So 2015 started off really cold, ended up really mild. 2016 started off really mild, ended up really cold by comparison. So it's very useful information. Overall, comparing the 2 years, we had 7% fewer heating degree days in 16 than in 15. Cooling degree days, we had 11% more. So we had more of an air conditioning load in 16 than 15. There's some other tabs here. One shows average temperature. You can show this for up to 15 years or so. Helps you to identify months that were really abnormal as far as their average temperature. This was a really abnormal Feb of 15, and a really abnormally mild points there. You can also show a cumulative chart of cooling degree days. It shows that calendar 2014 was a very mild air conditioning season. We had relatively few cumulative cooling degree days. And the same thing for heating degree days. I can run that on a seasonal basis. And it shows me that the heating season of 15 to 16 was very, very mild compared with some other years. And there's data here that you can copy to Excel. You can also show the degree day forecast. This is the next 14 days. This is updated daily. And it's telling me that the heating degree day forecast for Dulles is pretty low for the next 2 weeks. It's much lower than last year and much lower than the 3-year average. In other words, the winter weather in Northern Virginia for the next 2 weeks, as this was updated this morning, is going to be pretty mild. That's good news for my heating bills for Northern Virginia. So you can see this is useful information that can help you in your energy management program. With that, I am going to bid a fond farewell to the 4 sessions of cost avoidance webinars. Thank you very much. We will sign off now, and we will have the recording and the PDF available on the website soon. Again, thank you, and have a good rest of your day.